This is for Year 11 methods. We're going to look at exercise 5B, and these are domain and range questions. So remember the domain, just to recap, the domain is the range of x values the graph can take, and the range is the range of y values the graph can take. So if we look at 8a, we've got a hyperbola. Now in order to find the correct the correct domain and range for a hyperbola, we first need to find the asymptotes. Now, I'm assuming that people are getting this question wrong because there's a 2 at the front. So your natural response would be, oh, the x asymptote's at -5 and the y asymptote's at 3. Well, the y asymptote's right, but the x asymptote isn't. The reason because we've got a 2 at the front. Remember, whenever we have a number in front of the x, a number or a negative sign in front of the x, you need to take that out as a factor to really find out what the true left-right translation is. So what I physically mean is that if we have 2 on 2x minus 5 plus 3, I need to first take the 2 out as a factor, so it becomes 5 over 2 plus 3. So now I know my graph is going to have a x asymptote at 5 over 2, which is somewhere over here. X equals 5 over 2, and y is at 3. And we know this is a positive hyperbola, so it looks something like this. Now I don't need to find the x and y intercepts to find the domain range. Now I know in the x, well, if I look at the x values, the graph goes from positive infinity, so it goes all the way to positive infinity here, and it goes all the way to close to 5 over 2. It will never reach it because there's a vertical asymptote there. And over here, it'll go close to 5 over 2, and it'll go all the way to negative infinity. Now, the way to write that as a domain and range is, we know that graph naturally, so maximal means, what is the natural domain of the graph? Okay, so naturally, it can take up any value for x except 5 over 2. So how do we write that? So all values means reals, so domain is reals except for 5 over 2. Okay, some of you might write it like this. Some of you might go, oh, it's going from negative infinity to 5 over 2, not including 5 over 2, so negative infinity to 5 over 2, but not including it, union with 5 over 2, not including it, to positive infinity. Both are correct, but this is an easier way to write, so this is the preferred way. But if you wrote that on the SAC or test, that's fine. I'm not going to penalise you for that. Okay? So similarly, if we look at part B, we've got a square root graph. Again, there's a number in front of the x, so you need to take it out first to find out what the real translation is, left to right. Okay, so what you have to do is take the 2 out, so you get x minus 5 over 2. So it's basically a root graph that's been moved 5 over 2 to the right. Okay, remember, for root graphs, it does include that point, so don't exclude that point. So the domain of this graph would be, so the domain is the x values it can possibly take, so it starts at 5 over 2, 5 over 2, including it, to infinity, and remember, you always exclude infinity, okay, because we can't physically know what infinity actually is. It's just this is just an idea, so that's why we can't include it. We know it goes to infinity, but we can't include it. The range, so the range of y values would be 0, because it starts at 0 on the y-axis. Well, not on the y-axis, but it starts at 0, the 0 line. It goes up to infinity. Okay. Now, root graphs are very slowly increasing functions, but they do increase. So there's no asymptote at the top here. Okay, so it keeps on increasing, but very slowly over time. So the range would be 0, including 0 to infinity. Now, what the book writes instead of that is real positives, so all positive values, including 0. So there's 2 ways of writing it, both are fine. Okay. I forgot to find the range of the first one. The range of the first graph would be negative infinities because it goes all the way down there to it doesn't touch 3. It doesn't touch 3, but it goes all the way to the positive infinity. So the range of the first graph would be reals excluding 3. Okay, so the y value cannot physically equal 3. It can equal any other value, but it can't equal 3. So another one, part D. Now, for the test and SAC, you do need to know these graphs. You've got to be familiar with graphs learnt in chapter 3 and 4. Okay, so there's quite a few, but you're a method student, so you expect to remember it. Now, for that one, we know that the semicircle, it's the top end of a semicircle, so it looks like this. It has a radius of 2 and a center of 5, 0. Okay, so radius of 2, center 5, 0. 5, 0 is here. You do need to draw a rough graph to see where everything is. So it's going to look something like that. If the center is at 5, this will be at 3, and this will be at 7, and up the top, that will be goes up 2. So this will be so it will be 2 at the top there. So the domain is given by, I'm sorry, this is a bit messy. The domain would be from 3 to 7, and the range would be from 0 to 2, including. Okay. So that's basically how you approach these questions. Now for F, just in case you're wondering, that that square root sign, you can rewrite it as 4 minus 2x. It's 4 minus root x, and you've got to take the negative 2 out as a factor. Okay, and for part E, you do need to take the 2 out as a factor to get, the left-right shift. Okay, we can look at question 9. Sketch the graph of these following relations stating the domain and range of each. So if I make y as a subject, because we have y squared at the moment, I take the square root of both sides, so y equals to plus or minus root x. Now this is a relation because it's actually 2 graphs in one, okay, because you have the positive root and the negative root. So that's what it looks like. It's actually a parabola on its side. So the domain will be, it's starting at 0, domain will start at 0, and it will go to infinity. So you can say it's positive reals, including 0, so union 0, or you can say 0 to positive infinity. Both are fine. Okay. The range, this goes up forever, that goes down forever. So the range, nice and simple, to reals. Okay. With these other ones, it's just a rearrangement of these. Okay. So if you rearrange this, you can go x minus 1 equals y squared. So y squared equals y equals plus or minus square root of x minus 1. So it's you got 2 graphs happening here. You got the plus graph, so if it's plus, then x minus 1 means the square root graph, positive square root graph, has been moved 1 to the right, and the negative root graph, so it looks like that, has been moved 1 to the right as well. So it looks something like this. Domain would be, I won't go over this in detail, the domain would be from 1 to infinity, so including 1, and the range would be for reals, so similar. Okay, so all these questions follow a similar way of doing it. So just be really familiar with what these graphs look like, okay? Because you need to use this knowledge for the test and SAC, and be really good with finding domains and ranges. It's not rocket science, but at the same time you do need to practice a lot. Okay, hopefully that helps.